With both of these functions, the parent graph is the square root of x graph, which starts at the point 0, 0 and increases as it goes towards the right, but there's nothing on the left side of the graph. And that has to do with the fact when we have a square root function, that since we're just dealing with real numbers, when we take the square root of a 0 or anything positive, we'll get a real number. But if we start to plug in negative numbers, we're going to get imaginary or complex solutions. So that's why we say, well, square root of 0 is equal to 0, so that's our starting point. And then we can start to plug in, let's say maybe square root of 4, which is equal to 2, and that's how we get all of these other points. So the only difference for each one is that there's a negative in addition to the graph, and where the negative is makes a difference. So if we look at number 1, there's a negative attached to the function, but this negative is on the outside of the function. And so if there's a negative on the outside of the function, that indicates that there is a rotation, and in particular that rotation is about the x-axis. And the reason that this happens is by putting a negative right on the outside, whatever y value you would have normally gotten, we're converting that into a negative value. So if we look here, well, normally the square root of 4 is equal to 2, but if I figured out a negative on the front side of that, it would convert that to a negative 2. So it makes all the y values negative in this case, so it flips it about the x-axis. So it doesn't change the 0 value, so that will remain the same, but instead of increases as it goes towards the right, it's actually going to decrease. Then if we look at number 2, so g of x is equal to square root of negative x, there is a negative applied here, but it's inside the function. So still a rotation, but now it actually rotates about the y-axis. So you want to think about your original graph, and visually all we're going to do is just rotate that about the y-axis. So the 0 value is still going to remain the same, but now instead of going up towards the right, we're going to go towards the left. And what's happening here is that when we have that negative underneath, well, now I can't just plug in, let's say, a number of 4, because now we're dealing with a complex solution. But when I have that negative, underneath, in order to get real solutions, now I actually have to start plugging in negative x values, which is why you look at the graph and it's all the negative x values where there's a function or a graph attached to it. So now negative 4, for example, is the same thing as square root of a positive 4, which is positive 2. And that's sort of, my graph is close, it's a little bit off, and that's where that value comes from. And what you want to keep in mind with all transformations, whether it be horizontal, vertical, or rotation, or any other, is that you can always verify your graph by just plugging in some values for x, finding your values for y, plotting those points, and just making sure that they're in line with the graph.